Hi guys, in this video we are going to be talking about how to find the mean. We're going to look at how to find the mean just of a set of data. We're going to look at how to find the mean from a frequency distribution as well as from a grouped frequency distribution. So let's start off just by talking about what the mean is. So most of us are pretty familiar with the mean. We also know it as an average, and this is just the sum of all the data divided by however many data points we have in our current situation. So the formula for that would be for population, we would use the symbol mu. That's just a Greek letter that we use for population mean. It's how we identify it differently from a sample mean. And it's the summation of the x's divided by n. Remember that Greek symbol, the Greek symbol summation here, right here. That just means to add up all the points. So it's just telling you to add up all the data points, divide by n, which is the number of data points that we have in our scores. So for sample mean, you'll notice that the formula itself looks exactly the same. We have the summation of all of our x's divided by our number of data points. But instead of using our mu here, like we do in this first one, we're using the letter m. Some other textbooks you might also see, or some other people might refer as the sample mean as x bar. That's another way we can refer to the sample mean as well. Your textbook is going to use the large letter M. That's why I wanted to do that for you in this particular video. So the mean is considered the balancing point of all the data. It's the average or the middle of the data. But one of the things we need to understand is that the mean is highly susceptible to extreme values. Those are what we call outliers. And in chapter 4, we're going to talk a lot about how to figure out if your data point has outliers. Most of the time we like to look to see if we have outliers, and then what we typically do when we're doing research is we actually delete the outliers, or we take them out of our calculations because they're going to skew a lot of our information. So let's say we want to find the mean of the ACT scores of a sample of students from a high school. So we've got, in this instance, 14 scores, so we know our n is equal to 14. We are doing a sample since we don't have all of the students at this local high school. We just have a sample of the students. So we're going to use the formula with our m equals the summation of our x's over n. Again, it's not so much that the formula is different. We just need to really make sure that we're using the correct indicator, whether we're doing a mu, which is a population, or an m, which is a sample. I know that that seems to be such a strange stretch, but when we get further on into the course, it's going to be really important to be able to say something is a population mean or it's a sample mean as we're doing some other statistical tests. Okay, so once we get that, we're going to take all of those numbers up here in our chart, all 14 of them. We're going to add all of them together. And again, we're going to divide by 14 the number of scores that we have for these students. So all of that goodness on the top adds up to 320. We're going to divide that by 14. That's going to give us 22.85. And the rule of thumb for most of statistics, there are a couple exceptions, but for the most part, we always round our answers to one more decimal place than what our data has. So notice our data is all whole numbers. So being one more decimal place would be to round it to the 10th place or have one decimal place. So we would say that our mean is 22.9, rounding that 8 up since there's a 5 behind it. So the next thing we're going to do is we are going to find the mean from a frequency distribution, and this is just your standard frequency distribution. We have these scores 1 through 5. They occur in a frequency of this amount. And what we're going to do first is we're going to figure out how many data points we have. The way we do that is we just sum up our frequency column here. So we're going to add all of those numbers together, and we get that we have an n of 20. Now, to figure out what our numerator is going to be, what we're going to do is we're going to actually multiply the x times the frequency, and that's going to give us our f times x, okay? We're going to do that for each of these rows going down. So for the next one, we've got 2 times 3, which would give us 6, 3 times 3, which would be 9, 4 times 2, which would equal 8, and finally 5 times 1, which would equal 5. Now what we're going to do is we're going to add up all of these f times x's. So the 1, 6, 9, 8, and 5, we'll add that up. That's going to give us 29. So now when we find the frequency, and notice this time I am using a population, so I've got a mu here instead of an m, because this is all of the students in this particular class, which would be a population. So what we're going to do is we're going to take the summation, or that 29 that we just found from multiplying the x times the f and then adding that column up. That's our 29, and we're going to divide it by the number of students in the class, which was 20. So we've got 29 divided by 20, which would give us a 1.45. And again, since my data values are all whole numbers, my x's are all whole numbers, I'm going to round this to 1 decimal place, one more decimal place than what my data is. And I would say that the average score for this test was a 1.5. Now, this was a 10-point test, so I think that we might end up having to revisit this particular topic, whatever it happened to be in that class. Now, let's talk about a grouped frequency distribution. These are a little bit more work because we don't have an exact data point for every single frequency. We have a range of data points. So 2 things we've got to do. Again, we need to add up all of the frequencies so we know exactly how many data points we're talking about. So that's that frequency column here. And we add that up and we get that we're talking about 35 data points. The next thing we need to do, if it's not done for us, is we need to calculate the midpoint. I actually stole this particular grouped frequency distribution from one of our previous videos where we were creating this. So we had already created the midpoint. If you remember, we took the low, we added it to the high, and we divided by 2. So we did 10 plus 19, which is 29, and divided it by 2 and got the 14.5. And you can go through each one of these classes and do exactly that. Just take the high or the low and add it to the high and divide by 2. Or we talked about, we can do a little bit of cheating. Once I figure out the first one, I know that this is going to be the same width as my class width, which in this case happens to be 10. So I could just add 10 all the way down the entire list, just figuring out the first midpoint and then adding 10 all the way down. That'll give me my midpoints for my entire frequency distribution. So now what we're going to do, very similar to what we did on the previous, but this time what we're going to do is we're going to multiply our frequency times our midpoint. So we're going to do 6 times 14.5, and we would get 87. And we're continue doing that all the way down our entire chart here. So we've got 8 times 24.5, which is 196. 5 times 34.5, which is 172.5. 4 times 44.5, which is 178. 3 times 54.5, which is 163.5. 5 times 64.5, which is 322.5. And finally, 4 times 74.5 is equal to 298. And then what we're going to do, just like we did in the previous one, we're going to take and add up all of these numbers we just found in this last column. That's going to be our numerator for our mean. So adding all those up, we get that the summation of the frequency times the midpoint is 1,417.5. So we're going to take that 1,417.5 divided by 35, which is the total number of calls that we made that week, or per day, excuse me, for the last month. And we get 40.5. So there's an average number of calls. There's an average number of 40.5 calls per day. I hope this helped with the mean for a frequency distribution and a grouped frequency distribution. If you'd like another example, please reach out and I will be more than willing to provide that for you guys.